Let's see the equilibrium expressions for the gas containing systems. Here is a reaction, a balanced chemical reaction which is in equilibrium, and both the reactant and the products are in gas phase. So we can write the equilibrium constant using their concentrations. The product B raised to the power of the lowercase b divided by the concentration of A, which is reactant, raised to the power of A. And it's a gas, so easily for a gaseous system, we can easily measure the pressures of those components. Therefore, we can write the equilibrium constant using the pressure. So then it is the pressure of gas B raised to the power of B and divided by the pressure of gas A raised to the power of A. Right, so how we can relate the pressure and the concentration? Yes, we assume this gas behave like an ideal gas. So we use the ideal gas law equation and rearrange that equation. So, and we plug those things as an example. This is for A. So, PA, pressure of A times volume equals the moles of A multiplied by R multiplied by the temperature uh, uh, the RT. Okay, so next, what do we do? Yes, then we can take the V to the other side and we get the Na over V. What is N? It is moles. Moles divided by the volume equals to the concentration. So that is actually so if it is Pa equals the concentration multiplied by the R and T. This is the relationship between the concentration and the pressure. So then we can plug the values to the Kp, the equilibrium constant written using the pressure values. So when these are plugged in here, we get a final equation as the Kp equals Kc RT delta N. This is the coefficients, right? The stoichiometric coefficients found in the balanced chemical equation. Yes, delta N is the moles of gaseous products minus the moles of the gaseous reactants. This is the relationship between the Kp and Kc. Kp equals Kc RT raised to the power of delta N. N equals to the moles of gaseous products minus the moles of the gaseous reactants. Here is an example. The equilibrium constant Kc for the reaction N2O4 gas is in equilibrium with 2NO2 is 4.63 times 10 to the negative third at 25 degrees of Celsius. What is the value of Kp at this temperature? Yes, what is the equation? Kp equals Kc RT delta N. Right, we need the delta N. So what is the delta N? Yes, delta N equals the moles of gaseous products. How many moles in the gaseous product? What is the coefficient in front of the NO2? Yes, NO2 minus just 1 mole of N2O4. So then it will equals to 1. Right, so here it's 1. Kc, the value is given. You need to use this gas constant 0.08206 liters times atm divided by the Kelvin times moles multiplied by the temperature, must be plugged in the Kelvin temperature, and raised to the power of 1. So this is the Kp value.